Number 2, we're going to graph y equals 4 times the sine of x. Notice what's happening here. I have a number multiplying to the function sine of x. So it's the original y equals the sine of x times 4. So this affects, this is my amplitude. This is vertically stretching and shrinking those y values. So the original y values are 0, 1, 0, negative 1, 0. If I take that 4 off, notice you have y equals the sine of x. Those are those original y values times 4. Okay? So these y values are not going to be these original y values. You're going to take and you're going to multiply them times 4. 4 times 0 is 0. 4 times 1 is 4. 4 times 0 is 0. 4 times negative 1 is negative 4. And 4 times 0 is back to 0. So my y values are not going to be 1s and negative 1s and zeros. It's going to be 4s and negative 4s and zeros. Okay? So let's check the amplitude. The amplitude here is positive 4. Let's check the period. Okay, the period is the number in front of x. It's not the number in front of x, but that allows you to find it. It's 1, and you always do 2 pi divided by that number. So the period here is 2 pi. So my y values are changing to 4s and negative 4s. This tells me, according to my period, I'm still going to be a length of 0 to 2 pi. There is no horizontal shift here. So I'm going to have my original 5x values. So I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are going to be my 5 critical x values. Now I need to find the y values to go with those. Well, if I take an IT charted, let me go turn this light back on. If I took and I T-charted those exact values, those x values, y equals 4 times the sine of x. 0, pi over 2, and I'm only going to do 2 or 3 of them. I'm not going to go all the way through. If I plug 0 in, 4 times the sine of 0. Well, the sine of 0 is, what is the sine of 0? Sine of 0 is 0. So 4 times 0 is 0. So at 0, I'm at 0. Now plug in pi over 2. 4 times the sine of pi over 2. Well, what is the sine of pi over 2? The sine of pi over 2, that's this ordered pair here, is 1. So 4 times 1 is 4. So when I'm at pi over 2, instead of me being up 1, I'm going to be up 4. What do you think is going to happen at pi? Well, what's the sine of pi? Sine of pi is 0. 0 times 4 is 0. What happens at 3 pi over 2? Well, the sine of 3 pi over 2 is negative 1 times 4 is negative 4. And at 2 pi, the sine is 0. 0 times 4 is 0. So there's my sine curve. Make them as smooth as you can. Don't make them pointy and jaggy. Make them curvy. So there's your sine curve. Make this as curvy as possible. Don't make it look like an absolute value, V. Make it as curvy as possible. So there's your sine curve. If you'll notice, they have my y's, my 1s and negative 1s have stretched to 4s and negative 4s. So let's look at the maximum value. So the amplitude's 4. Period was 2 pi. If you'll notice, you are that long. The maximum is up at 4. The minimum y value is negative 4. The domain of any sine or cosine curve, remember, is all real numbers because this just keeps repeating forever in both directions. The range is the lowest y value, bracketed, negative 4 up to positive 4. The frequency, there was only one curve in that length of 2 pi, so that frequency is 1. And the midline is where all my x-intercepts are, okay? In this case, I'm on the x-axis, so my midline is y equals 0 in this graph. So there's all your information for that. Now I'm going to go ahead and do number 7. Number 7 is going to turn to a cosine curve. Notice you have a cosine curve, so I'm going to swap this out. I'm going to lay your cosine curve up here. Notice your cosine curve, your values start up at 1, go down to 0, down to -1, back up to 0, back up to +1. You still have your x values of 0, pi over 2 pi, 3 pi over 2, and 2 pi. All this information is identical, but when we draw a cosine curve, we have to have the look of a cosine curve instead of a sine curve, okay? So we're going to do the same thing. Look at number 7. You have y equals -2 plus cosine of x. Y equals -2 plus the cosine of x. Well, is this right here my amplitude? Is this being multiplied? It is not being multiplied to the cosine. It's being added to the cosine. So really, this -2 is a vertical shift. It's just written at the front. So this really says y equals the cosine of x minus 2. Okay, so there's that graph. Well, let's look at the amplitude. Keeping in your mind that this is going to start up at 1, go 0, go -1, back up to 0, back up to 1 when I get finished graphing. All right, so my cosine curve, the amplitude, there's not a number in front of my cosine, so it's 1, so the amplitude's 1. The period comes from this number in front of x. Well, it's also a 1, so 2 pi divided by 1 is 2 pi. So my period on this cosine curve is a length of 2 pi. There is no horizontal shift, so I'm going to be from 0 to 2 pi. There's no horizontal shift. So my first critical x value is at 0. My last one's at 2 pi. So those critical x values are the original, these originals right here. Okay, so they are my x values. Now I need to find my y values. Now, my original cosine curve, and this is just from me, okay, is up at 1, 0, down 1, back up 0, back up to 1. But I've got to take those original y values and x values, and I've got to shift everything down 2, okay? So my new, this cosine curve, y equals cosine of x minus 2, is this original minus 2 vertically. So I've got to take this point and move it down 2 vertically. I have to take this point, shift it down 2 vertically. I've got to take this one, shift it down 2 vertically. I've got to take the point at 3 pi over 2, 0, and shift it down 2 vertically. And at 2 pi, I've got to take that 1 and shift it down 2 vertically. So this is my cosine curve of y equals cosine of x minus 2. It has taken this original and shifted everything down 2. Okay? So let's find the maximum and minimum on this one. So the maximum value on this curve is -1. That's as high as it will ever go. -1. The minimum is -3. The domain is always all real numbers. The range is from the lowest y value, right here, to the highest y value. So from -3 to -1. The frequency